Number 8, we're talking about hemoglobin of the blood. And the question is how many moles of oxygen will be being released from a liter of blood containing 45 grams of hemoglobin that is transferred from 60 torr pH 7.6 to 20 torr pH 7.2. So basically, these questions, you need to interpret the graph that are given in order to calculate the moles of oxygen here. So you can see that at pH 7.6, 60 torr, you have 100% of oxygen bound to the hemoglobins. But once the pH turned to 7.2 and 20 torr, the percent of oxygen bound is reduced to 25% here. So now we know that the percent of oxygen is changing from 100% to 25%. So that means the oxygen that have to be released will be equal 75%. So next we have to look it up into the reaction between the oxygen and hemoglobin. So we know that one hemoglobin has to bind to 4 oxygen, right? So 1 mole of hemoglobin will bind to 4 moles of oxygen. So if we know that our hemoglobin is 45 grams, so we have to change grams into moles. So we divide the grams by the molecular weight here to get to the number of moles. So you get your hemoglobin would be equal to 6.6 times by 10 to the negative 4 moles. Since we know that 1 mole of hemoglobin react with 4 moles of oxygen. So it means that if you have 100% of oxygen bound, your oxygen moles would be 4 times by 6.6 times 10 to the negative 4 moles. But we know that from pH 7.6 to 7.2, you have to release 75% of oxygen. So you can calculate 75% of oxygen by times this value by 0.75, and then you get the amount of moles of oxygen that being released. Approximately, it is 0.002 moles. And this is the answer.